listen, the next, it's not quite as unique, it's more like an application of the previous one for integrals that have sine and cosine in them.
Like the rule of the tabulation?
No, it will be mostly using substitution for this one, but we'll see. Now, before I start, to solve these kind of integrals that have sine and cosine in them, such as this one, such as these ones, or that one, or negativity, you need to use trigonometric identities. Sorry. The problem is that these identities you're supposed to be having seen in Math 4. You remember in Math 4 we saw sum and difference identities at the end of the semester. Remember? No? What's repeated then? Okay.
El profe se explica mucho.
Es que no se vale, pues. Si no es que es palafo, si no es que llegan acá conmigo y me dicen, es que no lo vimos, bueno, pues es que, porque los mismos sí lo vieron, o sea, cuando di mate 4, pues, por ahí, ¿te acuerdas que sí lo vimos? Me te acuerdas, ¿verdad? Que lo vimos, lo vimos. Paola, Juan Pablo, que les di mate 4, Sofía, Bastante, Carlos, que siempre fe, las vimos. Okay, no problem. Fine. The idea is that we have formulas for sum and difference angles inside the formulas. And we're going to apply them to do what? To rewrite the integrals. Okay? So we have new identities for this semester. This first one, this one, this one, this one, and that one are called the sum and difference formulas. We saw them in Math 4, but it's fine. And from these formulas of sum and difference, we have other formulas, which are gotten from these ones, which are the product formulas or product identities of sine and cosine. So from these formulas come from this one. The good thing about this is that I'll try to convince the Liberians that we're going to give you this in the formula. I'll try to convince them, but we'll see. Okay? So, let's try one of the first ones, you see what I mean. For example, we have this integral. Integral of sine of 2x cosine of 3x dx. Okay? That's the integral here. Just by looking at that, it cannot be solved directly. Why? Because there's no identity for sine cosine. Now, the second thing. Could I apply directly u substitution to solve this one? No, I cannot. Why not? Because this sine has an argument which is 2x and the cosine has another one which is different, which is 3x. If they have the same argument, then no problem. u will be fine. But if they have different arguments, then you have a problem. Okay? There should be a way to rewrite everything so it can be solved. So for this one, for example, we're going to use one of those three formulas.
If they have the same, could we use the integration by substitution?
If they have, for example, 2x, or the same thing, you can just use this u, because they have the derivative in there directly. But if you have different arguments, substitution is not possible at the beginning. So, just observe, we have sine of something, cosine of something. We have these three formulas. What do? We're going to apply the first formula, not to solve it, to rewrite the integral. Okay? So, if you observe, you have sine of x, cosine of y, different stuff. We're going to rewrite into this. Okay? So now, for example, if I rewrite using that formula, sine x cosine of y is sine of x plus y plus sine of x minus y divided by 2. To rewrite. Let's do it. If I apply that, it will be sine of x plus y. What's x? This is x in the formula. This is the y in the formula. So 2x plus 3x, 5x. Plus sine again, but this time is x minus y. 2x minus 3x minus x. All of that over 2 dx. Okay? I just apply the formula to rewrite. Now what? if you observe, we have an addition between the sine and cosine. Now I can separate the integrals. So now I have an integral which is going to be sine of 5x over 2 dx plus sine of minus x over 2 dx. Two different integrals.
True.
Now I can solve this integral and I can solve that integral. Remember that yesterday we did an example with the tabulation part where I told you how to integrate this one directly? Not, if you don't remember, it's fine. We're going to do the whole procedure. For this one, we have integral of sine of 5x over 2, so you can rewrite that into 1/2 sine of 5x, right? If you don't think what to do, we could use substitution in this one. Because in this case, for example, I could say that my u will be 5x, and the du is what? What is the differential of 5x? 5 dx. Is the 5 in there? No. Can I change this one to match what I have in here? Yeah. There's no 5 dx here. I only have the dx and the sine, which is the big function there. So what I'm going to do is I'm going to multiply times 1/5. To cancel the 5. Cancel the 5. Why to cancel the 5? Because there's no 5 outside. But that's not a problem. So when you have a number here, but the number is not there, you can multiply times something to cancel it.
Mr. ¿Por qué du es 5x y du es 5x?
The derivative. The derivative. So my new integral is going to be the 1/5 times the 1/2 that I have at the beginning becomes 1/10 integral of sine, which is the one that I have, of u du. It's substitution. Do you understand what I did? Yeah. So can I integrate that? Yeah. It's going to be 1/10 sine of u integral minus cosine of u plus c, but I need also the other one. So this final part here is going to be minus 1/10 cosine of 5x plus c, or any other. De manera alternativa, se pueden ahorrar todo este paso y este paso lo pueden ahorrar. ¿Cómo se lo pueden ahorrar? Si lo ven esto como el inverso de chain rule. Si yo derivo seno de 5x, su derivada era 5 coseno de 5x, ¿están de acuerdo? Si estoy integrando, para ahorrar estos tres pasos, en lugar de multiplicar por la derivada dentro, divido por el coeficiente, que es 5. Por eso, y ese 5 que tenía, lo multipliqué por los que tenía, se volvió un décimo. Y ya me ahorré varios pasos. Si no, okay. That's the first one. For the other one, which is 1/2 sine of minus x dx, same situation. Well, think a little. Using the same reasoning, what will be my final integral for this one? I'll do the whole procedure, but right now, think a little. What will be the final one if I follow the same procedure? Plus 1/2 cosine of minus x plus c. Why? Because u in this case is minus x, du in this case is derivative of this minus dx, right? Minus 1 dx. There is no minus here. I multiply everything by minus 1. So my new integral is minus 1/2, the minus 1/2 integral of sine of u du minus 1/2 minus cosine of u plus c, which becomes this one. Do you understand that? Pero insisto, cuando son si seno, coseno, e al algo, se pueden ahorrar ese paso de hacer estas tres cosas simplemente en lugar de multiplicar como en derivada, dividir entre el coeficiente del argumento.
¿Lo divides entre 2?
Bueno, el 2 salió al principio del 1 medio. Entonces, este 1 medio es por este 2. Por la forma. ¿Sí? ¿Dónde? Sí, es que es esto, o sea, estoy aplicando U de U directamente, U de U directamente, pero te digo, si lo quieres hablar de estos pasos, véalo como el inverso de chain rule. En chain rule, o sea, cuando derivaba, ¿qué hacía? Derivaba lo de adentro, me quedaba el coeficiente y se multiplicaba. En integral, pues en lugar de multiplicar, divido. ¿Pero por qué?
Pero que hay el menos. Del signo negativo.
¿Este menos?
Bueno, del primero con este si solamente se divide.
Sí, claro. Si divide entre menos es como si multiplicara por menos. Así da igual.
Ya.
Por el menos que tenía del seno en su integral, que es coseno, pues se vuelve positivo. Ok, fine. Another example. Okay, number 2 for example, number 3, same situation, okay? Number 2 and 3, sine of 4x, sine of 7x, or cosine of pi x, cosine of 2 pi x, same situation. You need to apply one of those 3 formulas to separate what I did and do the same thing, okay? The same thing. Now, let's pass with another example, which would be the other parts. What happens if I have exponents in the sine and cosine? Okay, when I have exponents, let's do the first one. Let's try the first one. Can I erase? So I will need a whole one.
O sea, nada más divides lo que está en paréntesis entre el coeficiente de afuera
Ajá.
para no hacer la integral.
Ajá. Okay. Let's try number 4 because it's different. What happens if I have powers? Sine square of x over 2, cosine square, or cosine 4 power, etc. When you have even powers, even exponents. When you have sine and cosine with even exponents, you need to apply another identity.
You cannot use by. You cannot use the other one.
No. For those ones where you have even exponents, we're going to apply these two identities. When you have sine square of x becomes 1 minus cosine of 2x over 2, cosine square of x equal to 1 plus cosine of 2x over 2. To do what? To rewrite. We're going to rewrite. The idea is to lower the powers. To lower the powers to exponent 1, to power 1. To do what? To apply the formulas. ¿Ok? Esto también debimos haberlo visto en Mate 4, pero no nos dio tiempo por tanto rollo, pero con los de Prepe sí lo vi. Sí lo vimos. Sí lo vimos también. Si no se acuerdan, pues bueno, pero sí lo vimos. ¿Sí? ¿Por qué? Porque yo sé que los de Mate 6 necesitan hacer eso, pues lo vimos. Pero en fin, en este caso, in this case, for example, what do I do? You have sine square, cosine square. What do? You apply these formulas. How? Simple. Sine square of something, sine square of x, is going to become 1 minus cosine of 2x over 2. This argument here is always the double of this one. Double. What do I mean double? For example, if this is 5x, when I apply the formula, this is going to be 10x. If this is, I don't know, let's say like this one, x over 2, the double of that is going to be just x. So what I'm going to do is rewrite sine square of x over 2 is going to be with the formula 1 minus cosine of x over 2. That 2 is always the same. Huh? The only thing that is double is the argument. Times cosine square of x over 2. 1 plus cosine of x over 2 dx. Do you get that one? I just applied the formula to lower the power. To lower the power to power what? Then what do? Multiply. That 2 here, and that 2 here. 2 times 2 is what? 4. So it will be 1/4. The coefficient is 1/4. Why 1/4? Because in the denominator. Times 1 minus cosine of x. Porque es el doble del argumento. Si el argumento se empieza entre 2, el doble ¿cuánto es?
1.
Okay. Now what? We're going to multiply this times this. 1 minus cosine times 1 plus cosine is what? Very good. 1 minus cosine square of x dx. Exactly. 1 minus cosine square, so it will be 1/4 integral of sine square of x dx. Can I solve it now?
Yes.
How?
No,
Not yet. Again, the idea is to lower the powers again until the powers for the sine, cosine, etc. is 1. So in this case you have sine squared. What do? Apply the formula again. Apply it again. So it's going to be 1/4 integral of 1 minus cosine of 2x now over 2 dx. Yeah? I apply the formula again. But now my power is 1. Can I separate this integral? Yeah, that 2 multiply times the 4, so it's 1/8. Integral of 1 minus cosine of 2x dx. Can I separate my integral? Yeah. 1/8 integral of 1 dx minus 1/8 integral of cosine of 2x dx. I just separate. Si me preguntan, ¿por qué no haces seno? Porque no, esa no es la identidad. 1 menos coseno cuadrado sí es seno cuadrado. 1 menos coseno no es seno. Aquí nomás separé. Pum, pum. Can I integrate that? Yeah, now I can. Integral of, or 1/8 integral of 1? 1/8 x minus, same thing now, again, cosine of 2x. I will multiply u the u, or in a single step will be 1 over 16 sine of 2x plus 6. That's the solution. Remember, you could apply u the u, find it, etc. What I did in the previous example, or like I told you, when you have to integrate this, you have 2x here. The integral will be these 2 divided, so times 8 becomes 16, and the integral of cosine is sine. Why negative? Because this is negative.
Mr. How did you get the 1/4?
By multiplying 2 times 2. So I get rid of the denominators. And that's the answer.
And why 1 minus cosine x times 1 plus cosine x is 1 minus cosine squared?
Conjugated binomials. Conjugated binomials, remember? A minus b, a plus b,
Okay. Square.
y square. Ya.
Ya, ahora la integral, ¿por qué se hace menos 1 entre 16?
Because I'm integrating cosine of 2x. When I integrate cosine of 2x, the integral for that, because I have a 2, that divides. Times the 8 that I had at the beginning. That's the same. If you don't get why, just remember this. Cosine of 2x, if I do it with the complete procedure, I will need to choose u is 2x, du is 2dx, there is no 2, so you multiply times 1/2, which is the reciprocal to cancel the 2. So my new integral is 1/2 integral of cosine of u du. And at the end, 1/2 integral of cosine sine of u plus c times the 8 that I had. So that's the whole procedure. You can do it in single step. Exactly. The only problem will be, well, this is, let's say, the easiest or the powered ones. If I give you, for example, let's say, sine to the 4 power, cosine to the 4 power, or cosine to the 6 power, then I will take the whole board to do it. Until you reduce everything to power 1. Because the idea is to solve it in a single step, which is this one. There is no integral for sine squared. You need to do this. The idea is to reduce the power until you have power 1 by using the formulas. Yeah. Becomes double because that's the formula. It's the double of this. Good. Así es, que practicar. ¿Sí? O sea, yo entiendo que si está así como que digas, ay, pues lo va a trabar. Y sí, sí está como para trabarse, así que no es cierto. Pero sí, pero ahí es más bien contrario.
Mister, en esa verde no se llama cosine porque la...
No, de cosine de integral es sine.
Pero te dio negativo en el proceso.
Ajá, yo para negativo de dividir. O lo puedo demostrar, pero sí.
No, yo digo la verde. Porque la derivada de sine es cosine.
No era para hoy, era para mañana. O sea, que esto es hoy, mañana es los triángulos, que ya no va a fijar el papel mejor. El viernes, lo del viernes lo prefiero que sea así. Digo, a lo mejor okay. Okay, questions about this one? Now, listen, tomorrow, then with Tibe, I will not explain the next topic, but I need to work with the activities. The 1, 2, and 3. Substitution by parts in this one. Okay, before we go, if you have 4 minutes, I want to explain something else. Can I erase this?
Yes.
Nothing new, it's just a little extra. Oh, not extra, it's
Part of.
no, okay. ¿Se acuerdan que yo les di unas fórmulas para integrales? Que era, por ejemplo, integral de tangente, integral de secante.
Ah, sí, que estaban.
Eso es verdad. Entonces les dije, es que me da logaritmo de no sé qué, logaritmo de coseno, logaritmo de secante. ¿Okay? Y les dije, tienen una explicación. Entonces, se las voy a explicar para que vean dónde viene. Nada más estas dos, ya vamos terminando. ¿Sale? Ok. Observe this one, tangent. There is a formula for this, I know that. But imagine that you don't know the formula. You have tangent of x dx. What do you think would be the first step to try to solve this one? Forget about this one, not this one anymore. Right. How? Sine over cosine, very good. Sine over cosine, very good. Now, if you observe, this is basically what we did on Monday. There's a function there, and the derivative is also there. So it's basically u du. But observe, in this one, what would you say would be your u and the derivative? Why? Why not sine?
La integral de coseno es ahí.
No, that's not the reason. Acuérdense que yo puedo agarrar u de tal manera que también su derivada esté ahí. Entonces ustedes pueden decirme, ok, voy a agarrar u como seno y su derivada pues, es coseno y ya la hice. Pero el problema es que el de u no puede ir jamás en el denominador. Entonces no puedo poner u entre de u, ya la hice. No, jamás, no se puede. Por lo tanto, mi u es a fuerzas el coseno. ¿Sí? ¿Por qué? Porque su du, ¿cuál sería? ¿Cuál es la derivada de coseno? Ajá, negative sine dx. The derivative. So, if I rewrite that, it's going to be, there is no negative, so I multiply by minus. I multiply by minus, so now I have minus integral of du over u, which is minus integral of 1 over u du, same thing. Can I integrate that? What's the integral of 1 over u? Ln of u. So, minus ln of cosine of x plus c, which is the one that I gave at the beginning. Or the alternative is to say, okay, fine. You don't want cosine, you don't want a negative, that minus becomes the exponent of the cosine, so it's cosine to the minus 1, which is 1 over cosine, which is c. That's the real reason. Ah, no, but I wanted to memorize that. So fine, memorize the answer, but this is the reason. And I'll go with that quickly and we'll finish, okay? Coseno la menos 3. ¿Cómo se pasará los menos? Ajá.
¿Cómo?
El coeficiente está bien. Si lo pasas como exponente.
Okay, to finish. The secant. Secant is a little strange because you cannot just change it and that's it. Secant is a little strange and then you need to do something else, which in this case is to multiply tan secant plus tangent numerator and denominator, which is 1. It doesn't really matter. So at the end, if I multiply that, it becomes integral of secant squared plus secant tangent. I just multiply this times this times that, over secant tangent. Si me preguntan por qué secante más tangente, pues porque se puede. Esa es la demostración, pues, así es como se hace. This one, could it be done with substitution? Yeah. U is secant plus tangent. U is secant, derivatives. Tangent derivative. It's there. So, integral of du over u. Ln of u, ln of secant plus tangent. Si me dicen, es que cómo me puedo imaginar que es por secante más tangente, no es que se lo imaginen, por eso lo estoy diciendo yo a ustedes, es lo que tienen que hacer para poder llegar a la demostración y que les dé como resultado lo que les di al segundo día de clase. Y ya. Ok.